Hello, my name is Hanjun Cho, and this is Physics 2211 Lab 2, Charge Tape Revisited. So in Lab 1, we calculated the charge of our tape using a point charge model. But in this lab, the purpose of this lab is to compare Lab 1's point charge model to a new line of charges model in this lab to see how they differ in electric force and charge. And here are the preview of results. So similar to Lab 1, we'll also be using mostly the same physics principles, except at this time, we will add in a new equation or a new formula, which is the electric field of a rod, and I will talk about that later in this slide. So Newton's second law, Coulomb's law, and gravitational force are used together because in Lab 1, we determined that since the tape is stationary after we repel it, then force of electric force must be equal to the gravitational force. So there will be zero acceleration and zero velocity. So here are the Lab 1 conditions and results, just so you guys remember it, and later we'll compare it. So first off, we will start Lab 2 by calculating a new charge value. So we have the same conditions in Lab 1, mass, length, width, and distance, except we were solving for Q this time. So as always, we follow the same step. So electric force is equal to gravitational force. They're all equal to 1.96 times 10 to negative 3 newtons. And to solve for Q, we'll actually use the electric field of a rod instead of electric field of a point charge, as shown by my work here. So we will end up getting 2.11 times 10 to negative 8 coulombs instead. So now we have a new computational mod. So the end goal here is to, to see how lines of charges is different from point charges. So first off, we will divide this tape into multiple different segments. So I divide it into 50, and when I run my code, says I got 1.78 times 10 to the negative 3 newtons for electric force, and this is a little bit under the magnitude of the gravitational force. So if we use charge from we got from Lab 1, the electric force will be significantly smaller than gravitational force, as suggested by image 1 over here. So first image suggests that force of gravity is way bigger than force of electric force. Therefore, the top tape will actually be accelerating downwards. So here are some potential errors that I've made. So measurements and calculation during Lab 1 were not precise, leading to huge disparity between magnitude of electric force and gravitational force. I did not take into account of air resistance, and we assumed uniform distribution on the tape. Or another one, that during the handling of the tape, there was some loss of charges, or charges, being displaced into the surroundings, such as our hands or table. So additional question, what if the model was a point charge? Well, that's what we did in Lab 1. We used the electric field of a point charge. So comparing these two charge values, Lab 1's underestimated the magnitude of the charge necessary to balance gravity. And why? The estimates differs because we're dividing the tape into multiple little segments. So each segment will have their own charge and contribute to the total electric force of the tape, and that is following the principle of superposition. The more segment, the closer we are to the actual charge that is on the tape, which we cannot accurately assess at the moment. So for example, if I have 2,000 segments instead of 50, the electric force magnitude will be slightly closer to the gravitational force. Thank you.